So good afternoon, Samay garu. Welcome to the class. And yesterday we have discussed the centers of the triangle. Number one, centroid, which is the point of concurrence of altitudes. Number two, orthocenter, is a point of concurrence of, number one, centroid, it is a point of concurrence of medians. Number two, orthocenter, the point of concurrence of altitudes. Number three, the circumcenter, which is the point of concurrence of perpendicular bisectors. And the fourth one remaining is the incenter. So, incenter is a point of concurrence of internal angular bisectors. Let us take a triangle here. This is triangle ABC, let me say. And obviously there will be three angles for a triangle, everyone knows that. And this is angle A, this is angle B, and this is angle C. Now what is an internal angular bisector? If this angle A, for example, is 60 degrees, then this line divides it in the ratio, this line divides it into two equal parts, let me say. This line divides this angle 60 degrees into two equal parts. So, the internal angular bisector is that line which divides the internal angle of the triangle into two equal parts. So, this is a line which divides it, the angle, into two equal parts. If it is 60, 30, 30, if it is 90, 45, 45, if it is 120, 60, 60, like that. So, this is one internal angular bisector. This is one internal angular bisector, and let us take another one. This is another internal angular bisector. Let me draw this. Let me draw this. Second internal angular bisector, which is dividing this angle B into two equal parts, and this is third internal angular bisector, which is dividing the angle C into two equal parts. Let me say this as D. Let me say this as E, this as F. Then all these three internal angular bisectors are concurrent at the point I. Let me say, what is this I here? I is nothing but the in center. Why is it said to be in center? In center is that center of that circle. Is center of that circle which touches all the three sides of the triangle internally. Then how do we get its radius? The radius of this circle, in circle, is got by simply drawing a perpendicular line from any side, from the in center. Sorry, this is from in center. If you draw a line which is the perpendicular distance, let me say, from I to BC. Similarly, this is another perpendicular. Similarly, this is another perpendicular. So these are the three perpendiculars that are drawn to the sides. Now, what is it happening here in this case? The perpendicular distance from in center to any side is found to be equal. This length and this length, perpendicular, no? Or all the three are equal. So, because these three perpendicular distances are equal from in center I, if you take this as center, which one? I as center, what I mean to say, this I as center, and the perpendicular distance from this I to the side as radius. If you draw a circle, this is radius, smaller. The notation is also smaller. Standard notation is smaller. If you draw a circle, that circle touches all the three sides internally. That circle touches all the three sides internally. Let us see how it touches all the three sides. See, this is the in center and this is the radius. Now, if you draw a circle, that circle touches all the three sides internally. Okay. May need not be because it is the rough construction. Let me draw that. This circle will be like this. This is called in circle because it is in circle. The center is said to be the in center. Remember that. The center is said to be in center. So this is in circle. Okay. Now there are good number of properties. There are good number of properties here with regards to the in center. What are the properties that you have learnt in your lower classes itself are this. Number one, the internal angular bisector divides its opposite sides in the ratio of other two sides. What is that? Let me write it here. Number one, these two are the sides. Let me say A, B, C. The side which is opposite to angle C is said to be small c. The side which is opposite to angle B is said to be small b. Then if you take the side BC, then the internal angular bisector divides its opposite side. Then the internal angular bisector divides its opposite side in the ratio of the two sides, that is C is to B. Very important property, please. Very important property. You have good number of previous questions on this one. So the internal angular bisector divides its opposite sides in the ratio of other two sides, which is important. Number two, the incenter divides the internal angular bisector AD. This is AD is the internal angular bisector. This internal angular bisector is divided by the incenter in the ratio of, important please, in the ratio of B plus C is to A. What is A, please? The side which is opposite to angle A is nothing but small a. That is BC is A, please. BC is A. And what is AC? AC is B. And what is AB? AB is C. So the lengths of the sides are denoted like this, ABC. Now the internal angular bisector is divided by the incenter in the ratio of B plus C is to A. This is property number 2, please. Property number 2. Now, if you want to find out the formula for incenter, then this property is only used here. Now, but before that, let us fix the coordinates of ABC here. Let us fix the coordinates of ABC. Let A be x1, y1. Let A be x1, y1 and B be x2, y2. This is A, x1, y1 and B be x2, y2 and C be x3, y2. Then in that case, if this internal angular bisector AD is dividing the side BC in the ratio C is to B, if you apply the section formula, this D is nothing but, section formula please, everyone knows that, CX3 plus BX2 divided by C plus B, CY3 plus BY2 divided by C plus B is the coordinates of the point D here. Then if you take, we have already taken A as x1, y1. We have already taken A as x1, y. Now, D we know, this is D please. This is D. Again apply the section formula. Again apply the section formula. To find out I here, what is it? B plus C into this one. B plus C gets cancelled. And A into x1. A into x1. So what is the formula finally you get now? Ax1 plus bx2 plus cx3 divided by a plus b plus c. Next, if you apply y coordinate, very much similar to this only. A y1 plus b y2 plus c y3 divided by a plus b plus c. So what is not you are getting? The in-center formula is sigma ax1 by sigma a. Simply you can remember like this. Sigma ax1 by sigma a. Sigma ay1 by sigma a is the formula for in-center place. Generally, the formula is directly given. Generally, the faculty will not discuss this derivation in detail. So it is better if you understand this. The other concepts are linked to it. That is the reason why, if you understand this derivation, it will be useful further like this. Now, in the previous class, I have discussed. The harmonic conjugate points, if you remember, harmonic conjugate points. So those harmonic conjugate points are now very much useful here. Like what? I is the in-center here. Now, if you remember the definition of harmonic conjugate points, if I is dividing AD in the ratio B plus C is to A, then definitely there exists another point which divides it in the same ratio but externally. Here, the concept of X-centers arise. So, I is the internal, explained already. External ratio means you have to take one of them minus, that is B plus C is to minus A you have to take. So here, let us see what are the X-centers here. So remember this formula. Finally, the formula to find out the in-center of any triangle when the vertices are given to be x1, y1, x2, y2 and x3, y3. The in-center formula is sigma ax1 by sigma a y1 by sigma a. That is ax1 plus bx2 plus cx3 by a plus b plus c. ay1 plus by2 plus cy3 by a plus b plus c. Okay, now I am moving on to the X-centers now for your better understanding. What are the X-centers here? See, let me take again the triangle. This is triangle ABC. Okay. Now, this is internal angular bisector. Let me change the color. This is one angle A, this is angle B, this is angle C. This is angle A, B, C. Now let me change the color. Now, the internal angular bisector. Internal angular bisector of angle A is this. Now, understand this clearly, please. The in-center is the point of concurrence of three internal angular bisectors. Then, how the X-center is formed? In-center, X-center. How the X-center is formed, you know? Now, this is AB extended. This is AB extended. this is AC extended. Okay, now this is external angle. What does it mean by external angle here? If this internal angle is 60 degrees, the external angle becomes 120. This is 120 if it is 60. If it is 60, this is 120. If it is 30, if it is 30, it will become 180 minus 30, 150. So, what is the external angular bisector now? What is the external angular bisector? Internal angular bisector divides the internal angle, external angular bisector divides the external angle. So, this is the external angular bisector. This is one external angular bisector. This is another external angular bisector, and these three intersect or concurrent at the same point. At the same point, concurrent means they meet at the same point. So this is the point of concurrence of these three. So what is that you have to understand? What is that you have to understand here? See, this is third line is the internal angular bisector of third line is the internal angular bisector of external angular bisector of angle C. I am saying here three lines are there. What are the three lines? One is internal angular bisector of A. Second one is external angular bisector of B. Third one is external angular bisector of C. What I am saying, these three are intersecting at the same point. That is nothing but the point of concurrence. That is nothing but the point of concurrence. So this point of concurrence, we call it as the excenter, please. We call it as excenter. So this is excenter. This I1, why it is said to be excenter, why is it said to be excenter? If you take the perpendicular distance now, perpendicular distance from I1 to this side, if you take the perpendicular distance from I1 to this side, this is perpendicular distance. From I1 to this side, this is the perpendicular distance. From I1 to this perpendicular distance, this is the perpendicular distance. Now, by taking this as center, I1 as center, and this one as radius, R1, we call it as R1, standard notation is R1. If you draw a circle, that circle always touches all the three sides. That circle always touches all the three sides. This is like this. I'm poor in drawing, that is why you are not getting the circle properly. And this is a Exas Circle 1. The interesting fact is that this I1, I say, divides the line segment AD. What is AD here? Internal angular bisector. What is AD here? Internal angular bisector. I am showing it separately. This one, AD. This is AD. Okay. This AD is divided by the external angular bisector. That is the internal angular bisector AD is divided by this I1. That's what I mean to say. I1. Externally, in the ratio B plus C is to A, Because it is external ratio, we call it as B plus C is to minus A. B plus C is to minus A. So you can clearly say that. You can clearly say that if I is dividing it internally and I1 is dividing it externally, then I1, I2, this is I please, this is I is dividing it internally, I1 is dividing it externally, then I comma I1 are nothing but the harmonic conjugate points, remember. I comma I1 are nothing but the harmonic conjugate point. Then can you imagine now what should be the formula for I1 X center? X center I1, what is the formula? Can you imagine? What happens? Very simple. To the previous formula, you will have minus A, that's all. No change at all. Minus AX1 plus BX2 minus AX1 plus BX2 plus CX3 divided by minus A plus B plus C comma minus AY1 plus BY2 plus CY3 divided by minus A plus B plus C. This is nothing but the X center I1 formula, and this is called Exas Circle. Like this, you will have how many circles? You will have one circle this side, touching all the three sides. One circle this side. Touching all the three sides. How is it? Let me show you that. This is this side extended now. This side extended like this. This side extended like this. And similarly here also this side extended. Here also this side extended. Then you will have how many such circles? 3 such circles you will have. One circle touching all the 3 sides. Another circle. Touching all the 3 sides. You will have I2 here, X center. You will have R2 here, second X center, second X radius. Similarly, this side also you will have one more circle. So how many such circles exist here? 3 such circles exist here. For this one, you will have the X center I3 and this radius is said to be R3. So how the formula changes for I2? For I2, the formula will be simply AX1 minus BX2 plus CX3 divided by A minus B plus C, comma AY1 minus BY2 plus CY3 divided by A minus B plus C. And thereby you can understand how this I3 changes. I3 will be AX1 plus BX2 minus CX3 by A plus B minus C, AY1 plus BY2 minus CY3 by A plus B minus C. So like this, these 3 centers exist. So how many centers are there with respect to the triangle now? One is in center, I. Next one is I1. Next one is I2. Next one is I3. I1, I2, I3 are said to be X centers. I1, I2, I3 are said to be X centers. So what are the formulae now? For I, it is simply all positive, ax1 plus bx2 plus cx3 by a plus b plus c, comma ay1 plus by2 plus cy3 by a plus b plus c. For I1, a becomes minus a. For I2, b becomes minus b. For I3, c becomes minus c. That's only the difference you have to understand with respect to the in center. With respect to the in center. Now, if you join all the x centers, this is I1, let me say. This is I2, let me say. This is I3, let me say. This is I, let me say. Now, if you join I1, I2, I3, this is I1, I2. This is I1, I3. This is I2, I3. What is that you are getting? This is said to be X-central triangle, please. Because it is the triangle formed by, all the X-centers, we call it as X-central triangle. We call it as X-central triangle. So, interestingly, the in center of, very important point for the objectives, directly we can answer this, in center of triangle ABC is equal to X center of, ortho center of X central triangle. Ortho center of X central triangle. So what is it happening in this case? You have to understand, this is, just a moment. This is internal angular bisector, please. Internal angular bisector of triangle ABC. Internal angular bisector of triangle ABC is nothing but, this is I, please. This is I. Is nothing but altitude of the triangle I1, I2, I3. So very important point to be noted here is that this is internal angular bisector, internal angular bisector for triangle ABC, and this is altitude please. This is very important point to be noted. altitude of triangle I1, I2, I3. So what is that you all understand? The same internal angle of bisector of triangle ABC, the same internal angle of bisector of triangle ABC is the altitude of X central triangle I1, I2, I3. This is a point to be noted, and you have the previous questions also on this one. So this point is to be noted here. In center of triangle ABC is equal to orthocenter of X central triangle. Okay, this is about the centers of the triangle. So how many centers we have seen so far? How many centers we have seen so far? Mainly, number one, the centroid. Number one, centroid denoted by G. Number two, orthocenter, general denotation is H. And number three, circumcenter, generally denoted by S. Number four, incenter, generally denoted by I. And related to this, there are three X centers, I1, I2, I3. These are the centers of the triangle. You have one more center, 9-point center also there for the triangle, but that is not given importance, and that's not also there, of course, in the syllabus. So we will be concentrating only on these four centers. Now, very important relation between these centers, where the questions are asked frequently on this one is the centroid and the line joining. Let me say like this: the line joining the orthocenter H and the circumcenter S is divided by a centroid G. In the ratio, this G divides the line joining orthocenter and circumcenter in the ratio 2:1, please. In the ratio 2:1, very important relation. That is, this is orthocenter, this is centroid, this is circumcenter. The line joining these three are always collinear. If you take any triangle, in any triangle, all these three are collinear. So the centroid divides the line joining orthocenter and circumcenter in the ratio 2:1. Then if you apply the section formula, G is equal to 2S plus 1 into H by 2 plus 1, which is 3. So among these three, if you are given any two, you can find out the third one. What is that? If you are given orthocenter and circumcenter, you can find out the centroid using this formula, twice S plus H by 3. If you want H here, H is nothing but 3G minus 2S. If you want S, S is nothing but 3G minus H by 2. This is called Euler's line. This is called Euler's line. So, in a triangle, if you are given any two centers, you can find out the third one like this, using this formula. That is, centroid given, orthocenter given. Centroid given, orthocenter given, then you can find out the circumcenter using this formula. S is equal to 3G minus H by 2. Similarly, the other cases also. This is also important to be noted. Important to be noted. Now, let us see some problems today on this one, and after this, and one more area of the triangle remaining here. Let us see that, and then we'll move on to the problems. So, this is an important concept to be remembered. Euler's line important concept to be remembered, please. Now let us see the area of a triangle, area of a quadrilateral, area of a pentagon, area of a hexagon, area of a septagon, whatever. So I'm giving you a common formula for all this. The area of a n-sided n-sided polygon, please. N-sided polygon. How many vertices will be there for an n-sided polygon? Obviously, there will be n vertices will be there. A, x1, y1, B, x2, y2. Let me say a1, a2. This is a1. This is a2. x2, y2. x3, y3, a3, x3, y3, and a4, x4, y4, and so on. an, xn, yn. What I am doing now, all the formulae of area of a triangle, area of a quadrilateral, area of a pentagon, area of a hexagon are packed into a single formula like this. Please follow this carefully. This is half modulus of x1, y1, x2, y2, x3, y3, x4, y4, and so on, xn, yn. Finally, x1, y1. For every geometrical figure, finally you have to write x1, y1. That is, if you want to find out the area of the triangle, take like this: x1, y1, x2, y2, x3, y3. Finally, x1, y1. If you want to find out the area of the quadrilateral, x1, y1, x2, y2, x3, y3, x4, y4. Finally, x1, y1. If you want to find out the area of the pentagon, x1, y1, x2, y2, x3, y3, x4, y4, x5, y5, x1, y1. That means for a triangle, n becomes 3. For a quadrilateral, n becomes 4. For a pentagon, n becomes 5. For a hexagon, n becomes 6, and so on. Finally, x1, y1 lies. Now, square your x. But how to calculate this? Top to bottom plus x1, y2 minus x2, y2. Top to bottom plus x2, y3 minus x3, y2. Top to bottom plus, bottom to top minus. Cross multiplication, please. Very simple. Cross multiplication. We can also call it as matrix multiplication. Okay, this is the common formula to find out the area of any geometrical figure, any closed geometrical figure, let me say, any closed geometrical figure. So if we take an example, then you will better understand it. If you take an example, you will better understand it. What is that I wrote here? I wrote here as n-sided polygon, please. Something it is messy, that is why I am writing it in here. Polygon. N-sided polygon. Now, if we take an example, you will better understand it. If we take an example, you will better understand it. See here, please. I'll do it here, and then we'll move on to the questions. That is, let me take a three vertices first for a triangle. A 2 minus 3, B 5 3, C minus 1 minus 2. If or vertices of a triangle, or vertices of a triangle, then delta ABC. What does it mean by delta ABC, please? Area of the triangle is given by half. Of course, you know, in your lower classes you have learned it as a formula. Everyone might be remembering the formula, but what I'm doing, I'm just giving you a common formula. One formula for triangle, another formula for quadrilateral, another formula for pentagon. It's not like that. It is a common formula which can be applied to any closed geometrical figure where the vertices are given, n vertices are given like this. So now it is 2 minus 3, 5, 3, minus 1, minus 2, 2, minus 3. Okay, now what is that I said? Top to bottom plus bottom to top minus. Top to bottom plus bottom to top minus. Top to bottom plus bottom to top minus. That's what we're doing now. Mind calculation, please. Mind calculation. 6 plus 15, 21. Minus 10 plus 3, minus 7. And 3 plus 4, 7. Answer is 21 by 2, please. Answer is 21 by 2. It is 10.5 square units. I have taken the area of the triangle using this formula. Now, let us move on to pentagon. Let us take, for the sake of practice, let us take a pentagon, please. Let us take A 2 minus 1. B 4 2. C minus 1 minus 3. D 2 minus 3. and E, let me take minus 2 minus 3. Minus 2, 3. E 3 minus 2, or the vertices of a pentagon. Then area of pentagon ABCDE is equal to half modulus of. Yes, you understand that this is 2 minus 1, 4, 2, minus 1, minus 3, 2, 3, 3, minus 2, finally 2 minus 1, it is to be written, please. It is to be written. Just understand that. Now, top to bottom, bottom to top, calculate like this. 4 plus 4, it is 8, and it is minus 12 plus 2, minus 10, minus 12 plus 2, and it is minus 3 plus 6 plus 3, and minus 4 minus 9 minus 4 minus 9 minus 13, and it is minus 3 plus 4, minus 3 plus 4, please, minus 3 plus 4 plus 1. So what is the final answer here? Half modulus of, this is minus 2, this is 1, 1 plus 1, 2, 2 minus 13, 11, so it is minus 11, of course modulus is there, it is 11 by 2, so 5.5 square units is the area of the pentagon. So this is a universal formula which can be applied to any n-sided polygon. So remember this, this will give you a comfort not to remember area of the triangle separately and area of the quadrilateral separately, area of the pentagon separately. It combines all the formulae. It combines all the formulae. Okay. Now let's move on to the problems here. Just see this. First problem. ABC are the points AP, BQ, CR respectively such that ABC are in AP and PQ are in GP. If the points are collinear, then P is equal to Q is equal to R, P square equal to Q, Q square equal to R, R square equal to P. So, let us understand that. Let me check. First point, please. A. What he's saying is AP. What is B? BQ. What is point C? CR. These are the points given, and it is given that ABC are in AP. So I will take like this: A1, B2, C3. PQR are in GP, he said. I'll take this 1, 2, this as 4 because he gave that PQR are in GP. Just check it out. A, B, C. What is that? A, B, C. A, B, C. 1, 2, 3. PQR 1 to 4. They are in GP. I hope you understand what I am saying here. What is that? This is ABC or this, and PQR or this. Okay, now let us check. Let us check the options. First option, please. P is equal to Q is equal to R. No. 2. 1 is not equal to 2. Q square is equal to R. What is Q here? 2. 2 square is equal to 4. 2 square is equal to 4. R square equal to P. 4 square is equal to 1. No, it's not possible. So, what should be the final answer in this case? Q square is equal to R is the final answer. This is getting satisfied. Because Q we have taken to be 2, R we have taken as 4, 2 square equal to 4. So that is the answer. Okay. Now, going to the next question. ABC are 3 collinear points. AB is equal to 2.5 and the coordinates of A and Z are respectively 3, 4 and 11, 10. Then the coordinates of point B are. It is simple, you can verify like this because AB distance is given to be 2.5 and the points are given to be collinear. This is A, this is C. This is A, he is saying. This is C. And B is in the options. B is in the options. Now, if they are collinear, then the area formed by these points must be 0 because they are collinear. So let us check whether the area becomes 0 or not. Delta ABC, please. Delta ABC. First option, I am verifying first option. Half modulus of let me write the points there. What are the points? Points are 3, 4, 11, 10. 3, 4, 11, 10. And option, please. First option, 5, 11 by 2. 5, 11 by 2. And finally, the first point again, x1, y1. What is the formula now? x1, y1, x2, y2, x3, y3. Again x1, y1. Now, apply the cross multiplication method or matrix multiplication method. Mind calculation, please. 3 into 10, 30. 30 minus 44. 30 minus 44 minus 14, and it is 11 into 11 by 2, that is 121 by 2. minus 50, and it is 5 into 4, 20, and it is minus 33 by 2. Just check. This is plus 6. The positive quantity is more here. The positive quantity, let me check. This is plus 6 here. Plus 6 means, yes, positive quantity is more here and it is not equal to 0. And hence, it is not the first option, please. Not the first option. Then you have to go for the second option, third option and fourth option. Then whichever satisfies, that will be the answer. Similarly, 511, instead of 511 by 2, we will write 5 by 2. In the next case, we will write 111 by 2. Let us see that. Let us see that. Second option is 5 by 2. We are now verifying B. This is 5 by 2. Five by 2, if you write now, this won't change. 30 minus 44 minus 14 I wrote. 55 by 2 you'll get here. by 2 minus 50. That is not also getting changed. And this is 20 minus 15 by 2. You have to count this. This is minus 64 plus 20 minus 44. Minus 44, this is not equal to 0 again. So B is not also the answer. This is not also the answer. So if you check C now, you will understand whether it is if C is not the answer, obviously it will be D only. This is a cross verification process. You have the method also for this. You have the method also for this. And method, if you sometimes the method becomes lengthy, and in that case we go for cross verification like this. Okay, now let us substitute C. Let me write that. Here the fractions are given, that is why it is taking more time. If integers are given, it becomes easy for you. So 1 comma 11 by 2, if it is there, then it is 30 minus 44 minus 14 is same. It is 121 by 2, that won't change. Like the first one, you got it for 121. Minus 10 is this. Minus 10 is this. And it is 4. It is 4, please. So, this is 4 minus 33 by 2. Let us say this, minus 6 minus 20, and it is not also 0. Not also 0, it is understood. So, your answer must be D. D should be your answer. Let us check. Let us check whether D is the answer or not by writing the coordinates there. What is D? Let us see. What is D here? 1 comma 5 by 2. This one is 5 comma 5 by 2. This is 1 comma 5 by 2. 1 comma 5 by 2. Let us see this now. This won't change, minus 40, and it is 55 by 2, please. Minus 10 is correct. This is plus 4 is correct. Minus 15 by 2. This is minus 15 by 2. Let us see this now. Whether it is 0 or not, it must be 0 because first three options are not satisfied, it must be 0. You may be thinking that it is taking more and more time, but if you practice it, it will take less time. This is minus 20, please, and it is 40 by 2, plus 40 by 2, plus 20. It is 0, so your answer is D, please. Your answer is D, because they are collinear, and you can further, if you, sometimes you may be getting double answer also. When you get double answer now, then you will find out the distance between this A and the answer. A and the answer. This must be 2.5 square units. The 2.5 units distance is given to be 2.5. Then you can go for that verification. Okay. Now this is the next question. The points x comma 2x 2y comma y 3 comma 3 are collinear. If they are collinear, the area of the triangle becomes 0. So let us do that. X 2x 2y y 3 3 are collinear. So when they are collinear, the area must be 0. The area must be 0. Let us take the area now. X 2x 2y y. What is the other point? Let us see. X 2x 2y y 3 3. And again x 2x. Must be 0, please. Then what happens? I'm writing this directly, please, because you understand by now. This is cross multiplication method. Xy minus 4xy, which implies minus 3xy. Xy minus 4xy. 6y minus 3y plus 3y. And it is 6x minus 3x. 6x minus 3x plus 3x must be 0 because they are given to be collinear. Now from this one, what is that you are getting? X plus y is equal to xy. Then you will get, if you rearrange it now, x by xy plus y by xy is equal to 1, which implies 1 by x. This is 1 by x plus 1 by y is equal to 1 you have got. Now I have to remind you now the progressions, 3 conditions. Number one, A, B, C are in AP. A, B, C are in AP implies 2B is equal to A plus C. I hope everyone knows that. You have got it in your lower classes itself. Number 2, A, B, C are in GP. then B square is equal to AC. Similarly, A, B, C are in HP. Generally, it is neglected and you don't have this in your lower classes. HB is not there in the lower classes. Simply understand HP is the reciprocal of AP, please. If you write these terms as reciprocals 1 by A, 1 by B, 1 by C, then they are in AP. All the terms of HP, when you write the reciprocal, they must be in AP. Then for this one, you do know the condition, it will be the same. This A becomes 1 by A, B becomes 1 by B, C becomes 1 by C. Then replace them. Then what is that you get? 2 by B is equal to 1 by A plus 1 by C is the condition. This is the condition, please. Then in that case, what happens? If you compare this with this one, you can write this in this way: 1 by X plus 1 by Y is equal to 2 by 2. 2 by 2. So what is that you have got in place of B, please? What is that you have got in place of B? In place of B, this is B here. This is B here, please. And this is B here. Compare. Compare, please. What is the B here? This is B in this case. What is A here? X. What is A here? X. What is B here? 2. What is C here? Y. Or in HP. This is the condition, please. Or in HP. Let us check it out. Now this is for all values of xy, it's not true. 2 is AM of xy. No, it is not arithmetic mean. 2 is GM of xy. No, it is not geometric mean. 2 is HM of xy. So x2, y are in HP. So 2 is in between x and y. So x2, y are in HP. So the answer is 2 is HM of xy is correct answer. Is the correct answer. Okay. So we have used the area of the triangle formula only to solve these problems. Okay. Now, going to the next question, please. This is a little lengthy question because if you observe the points, T1, 2a, T1 plus 81 cube. T2, 2a, T2 plus 82 cube. T3, 2a, T3 plus 83 cube. Are collinear. Then the condition is. Here also, you can make use of the area of the triangle. And if you know the slope concept also, slope concept can also be comfortably used. Slope concept, you might have learned in your lower classes itself. Slope of a line joining 2 points x1, 1 and x2, y2 is equal to y2 minus y1 by x2 minus x1. y2 minus y1 by x2 minus x1. You can make use of it. Of course, the question is given to be a higher level question. So this point is also little lengthy. Even then, let us work out. Let us see that. See, what are the points given? Let me write that. Let me write the points given. First point, please. First point. T1 comma 2a T1 plus 81 cube. T1 comma 2a T1 plus 81 cube. T1 comma 2a T1 plus AT1Q. Second point is symmetrically given T2 comma 2a T2 plus AT2Q. Third point is going to be T3 comma 2a T3 plus AT3Q. Check it out once, whether the points are correct or not. T1 2a T1 plus AT1Q. All are symmetric. That's correct. So, if you apply the concept of area of the triangle, it can be worked out. If you apply the concept of slope also, you can solve it. So, or collinear given implies slope of AB is equal to slope of BC. Let me write slope of AB so that symmetrically you can write slope of BC. y2 minus y1 by x2 minus x1. I am writing direct step here. Just try to understand that. This is x1 y1, this is x2 y2. y2 minus y1 by x2 minus x1. If you write y2 minus y1, you will get 2a common. You will get 2a common. Within brackets, you will get t2 minus t. Okay. Within brackets, you will get t2 minus t1. This one, t2 minus t. Here also you will get a common. Within brackets you will get t2 cube minus t1 cube. A cube minus b cube formula. A cube minus b cube formula. A cube minus b cube. A minus b into a square plus ab plus b square. I hope everyone knows this formula. Divided by x2 minus x1, t2 minus t. Okay. Now you can take t2 minus t1 common, that gets cancelled. You can take a common also here. So what is that you get now finally? A into 2 plus a into 2 plus t1 square plus t2 square plus t1 t2. Because these are the symmetric points here. These are the symmetric. We are not writing this slope of BC. Now we will write this because these are the symmetric points here. Instead of t1 here you will get t2. Instead of t2 here you will get t3. That's only the difference. So a into what is that you get? 2 plus t2 square plus t3 square plus t2 t3 please. Then you will get a cancelled. You will get 2 cancelled. You will get t2 square also cancelled. Then what is that remaining here? Just see. t1 square plus t1 t2. I am writing it here. t1 square plus t1 t2 is equal to t3 square plus t2 t. Now just let us see what are the terms that we will get common to get the answer. To get the answer, what is a simplified form of it? Let us take any factors that are involved in this one. T1 square minus T3 square. T1 plus T3. A plus B into A minus B. A plus B into A minus B. I wrote these two. Plus in these two, what is that you get common? T2 you'll get common. So take T2 common. What is that you get? T1 minus T2. Just observe. You got T1 minus T3 common. And what is that you get in the brackets? T1 plus T3 plus T2 equal to 0. Because he mentioned in the beginning, you can see that. He mentioned in the beginning that T1, T2, T3 are distinct or distinct. Distinct means they are not equal. Then what is the condition? So for this one, here T1 is not equal to T3. Here T1 is not equal to T3. He mentioned in the question. That is the reason why final answer should be T1 plus T2 plus T3 is equal to 0 should be your answer. Okay, so final answer, if you check, it is T1 plus T2 plus T3 is equal to 0 is the final answer. I hope you understand that. Let us recheck it. Let us re-understand it. These are the 3 points given, are given to be collinear. What I did, I have taken slope of AB is equal to slope of BC because they lie on a line. When they are lying on a line, obviously their slopes are equal, or you can even try with the area of the triangle. But with the area of the triangle, it becomes little lengthy. That is why I have taken this as slope. Slope of AB is equal to slope of BC. So here also, just mind calculation. Mind calculation, while you write y2 minus y1, you will get t2 minus t1 common here. In the denominator also you have t2 minus t1, that gets cancelled. You will get slope of AB like this, A of this one. And in this, because these points are symmetric, we wrote slope of BC also similarly, and we cancel those terms that are common on both sides. Now we are factorizing it. This is t1 square minus t3 square, which is bring it to other side. T1 square minus t3 square, a square minus b square, a plus b into a minus b. And here bring this to other side, take t2 common. You get t1 minus t3, t1 minus t3 common here, and within the brackets you get t1 plus t2 plus t3 is equal to 0 is the final condition you have got. Okay, in the simplification you have to take care. Okay, now coming to the last question here, 120. Minus a minus b 0 0 ab a square ab or collinear. Vertices of a rectangle, vertices of a parallelogram, none of this, none of this. See, this is simple. Let us take the first 3 points. It is common sense. It is common sense that by observation, you can see these 3 points are collinear if you draw them on the plane with the axis. With the axis, like this. This is y-axis. This is x-axis. This is the horizon here. And let me take AB somewhere here. then minus A minus B. Minus A minus B will be here. That's what I'm saying, common sense. When these three are collinear, they are forming a line here. They are forming a line. If you want to check, whether they are collinear or not, with the common sense also, you can say that's what I have drawn the diagram. These are three collinear points. Now, if you want to know further whether the area formed by them is 0 or not, this is simple. 0, 0, AB minus A minus B, 0. Of course, half will be there. Minus AB plus AB, 0. Area of the triangle is 0 and hence those 3 points are collinear. When 3 points are collinear, the fourth point, if it lies on the same line, then we say that all these 4 points are collinear. But A square comma AB will not be lying on this line. Just you can give some values to AB. You can check it like that also. Or otherwise, conceptually or methodically, if you want to understand, I'll show you that. 0, 0, AB, A square AB must also be collinear if the answer is collinear. So let me write that. 0, 0, zero, 0. This is AB. This is A square AB. Finally 0, 0. Just check. A square B. 0, 0, AB, A square AB. A square AB. Zero, 0, AB, A square AB, and 0, 0. What is that you are getting? You are getting 0 here also from this. A square B. This is anyway 0. This is A square B minus A square. A square B minus A square becomes 0. So they are collinear. They're all collinear. Okay, they lie on the same line. Okay, and in the tomorrow's class, what I'm going to take is this part, this change of axis. These are the problems related to change of axis. And then this is the locus problems. This is locus. And then these are change of axis, transformations, successive transformations and all this. Okay. The title I have given to be, I gave the title as Introduction, Change of Axis and Locus. It has taken this much of time to explain you this introductory part. Now, in the next class, in the tomorrow's class, I'll be taking locus and change of axis. Locus is very, very important, as I said in the beginning classes. Locus, without locus, I say there is no coordinate geometry. That's what I said in the beginning also. So locus is a very important concept. So we will understand locus at length, and we will discuss the problems also, because all the problems in the coordinate geometry, most of the problems are related to locus only, and the students are generally getting doubt in finding the locus of a particular problem, because there is no proper understanding to the concept of locus. Okay, I'll take tomorrow's class, locus and change of axis. Namaste.